Okay, so now let's get started with the data types. Okay, so data types in Java, and okay, we are beginning with this new topic. So data types in Java have been categorized into two.
Yes.
Okay, we got types which we call as the primitive types, and the other one is called the reference types. Okay, fine. So let's understand. Fine. What are the primitive types as well as what are the reference types? Okay. And I'll just first look at the listing, categorization. So what are the primitive types? The data types. Yeah, we have the byte.
Short.
Okay.
Integer long.
Short.
Integer long.
Int. Long.
Float and
Float.
double.
Double. The char. Okay. And even a boolean.
Okay.
These are the primitive types. Okay. For the reference type, I'll just put here, we'll discuss them a little later. Any, we created those types. Yeah. Okay. Oh, we used arrays. So arrays are reference type.
Okay.
Any kind of an array of any type.
Okay.
Okay. And for any type, you can have a array created. So arrays, we can define classes. We can define interfaces. We can have enums, and we have the annotations. And other thing is a record. So these are all the various kind of reference types. Okay, fine. So reference types are 6. Arrays are also there. Okay, fine. And these are the primitive types. Okay. Again, as far as those classes are concerned, okay, we have a few relationship between the primitive types and a set of classes. Okay, we have something called the wrapper class. Fine. So we understand. So I'm just giving a few names of the classes here. Okay. So if you look at the wrapper classes, we have. I'll list both the types. We understand this. Okay. I'll just pick this up. Okay. Wrapper classes to each primitive type. Okay. So we have wrapper classes corresponding to each of the primitive type. Okay. So we have the type called byte, for which, okay, there's a common prefix which I'm not putting. It's java.lang. Okay. So we have got a class called byte. Class names conventionally always start with a capital letter. Okay. We have a class called short. We have a class called integer. We have a class called long. We have the class called the float. We have the class called the character class, and we have a class called. Okay. Now, other than this, other than the wrapper classes, also there's one more class which I'll just mention here. Okay, you may not call it as a wrapper class, but we have a return type called void, right?
Yes.
Okay, so even for this, there is a class called void. Okay, and so this is just a list of some of the classes which are available. Okay, now. Okay, so now let's get started with the primitive types. Okay, so if I look at the primitive types, So primitive types, if you look at the whole, all the types, right? At the top level, we can divide it into two categories. Okay, one is numeric, and the other is Boolean. Okay, fine. See here, Boolean is a separate type, unlike the C language. Okay, it's not like the C language. In C language, Boolean is a numeric type.
Okay. In Java, Boolean is a separate.
Actually, it's a numeric value only,
Yes.
as far as C is concerned. Okay, it just says 0 or non-zero. Non-zero is true, 0 is considered as false. And see, for example, in case of a C language, someone says if I might have an int value, right? I might say int a equals 5. Okay, and if someone says if a, this is valid, right? After if, what is needed? A Boolean value. So this is valid for C language, but not in case of Java. Okay, for Java, this is not a valid thing. It says I need a Boolean only. You can't be using a int here. Okay, so 0 non-zero is true, false. No, that doesn't work here in Java. Okay, it will have to be. So they are a separate type. Fine. So the two primitive, numeric and Boolean. Okay, fine. Under numeric, so if I just go to, okay, under numeric, so let me put this. We can say integral type, and we have the floating point. Okay. Okay. What are the integral types? Acha. Okay. What are the integral types? Oh, we have those types, right? The byte, short, int, long, and char also, right? Okay. Now I'll have to just categorize again. Okay. These ones. Okay. I'll put them as the signed types. Okay. These are the signed types, and we have the unsigned, which is char. So char is the unsigned type. Okay. When clear, these are the data types, right? This and here. So this is unsigned. Okay. We need to know the sizes of each of them, the range. It's a signed type. That means it has from negative to positive. Okay. This will only have 0 to 2 to the power of n minus 1, where n is the number of bits available. Okay. For floating point types, okay. Now, one thing I should mention here, floating point is according to a standard, fine, IEEE 754. Okay. So you should try to refer to what is this IEEE 754. Okay, fine. Go through that link. Okay, find and see what is IEEE 754. Okay, so IEEE 754 talks about single precision and double precision. Okay, single and double. Basically, they call it a single and double. Okay, so that single there of IEEE 754 is our float. Double is our double precision. Float and double are like this.
Float is a 32-bit.
Okay, let's put the size for each of them. Okay, I think we'll put it in bracket. Okay, how many bits? 8 bits. Short?
16.
Yeah, 16 bit. Int? 32. And long will be 64. Char? Char, how many bits for char type?
N number 0.
No, how can it be 0?
One byte.
Okay, it is actually not 1 byte, it takes 2 bytes. Uses 16 bit. Okay,
Hmm.
it uses Unicode. You heard of Unicode? No? Okay. You know ASCII?
Yes.
ASCII. Okay.
Yes.
Okay. And okay, yeah, Jagdish, any idea about Unicode?
Um,
Okay.
yeah, I know about Unicode, but currently I'm not
Okay.
providing the definition.
Okay, fine. Fine. So Unicode basically is about. Okay. Now, once this topic of Unicode comes, fine. I'll just tell you one more thing about the identifiers. Let's talk a little about identifiers. Okay, we'll compare identifier in C and identifier in Java. Rules for identifier. Okay. Okay, let me fill this up. This will be 32 and this is going to be 64 bit. Okay. Yeah, it should be. Okay. I will put three rules here. One is what it can have, right? Okay. Uh, Fine. May contain letters, digits, or as far as separator uh, like underscore. Okay. Okay. And dollar. Okay. When this is what we know from C language, that this is what it can contain. And second rule is, okay, cannot start with a digit. Okay. And third rule says cannot be a reserved keyword of the language. Okay. Fine. These are the three rules. Fine. Okay. Now, okay, this is Windows. I may not be able to show you the things here. Okay. I'll just switch to Linux. Fine. I'll just connect to my Linux machine and okay. Yeah, to show you, I'll have to do some more things. Okay, I think I'll do it on the board here. Okay, let's check what are the valid identifiers, right? Okay, so yeah. Anyway, so if I say, okay, you may start with a dollar, right? You cannot start with a digit. Okay, so we understand A is a valid identifier. We very much used it also, right? Okay. What about you know what this is? Gujarati letter A, right? So is it valid identifier? Yes or no?
Yes.
Because it is a letter. Fine.
Yes.
Okay. Fine. Or okay, I think before a dollar, let me use one more. Yeah. Okay. So 1A, valid identifier? No. Cannot start with a digit. Okay. Valid identifier?
No.
No, cannot
No.
start with a digit. Fine.
Okay, sir.
Okay. Valid identifier? Yes.
Yes.
Now you are starting with a dollar,
Mm.
right? It's not starting with a digit.
Okay. Yes.
Valid identifier.
Right.
Clear? The rules are the same as what we find in C. The difference is in C language, it was the ASCII character set. Here we use a Unicode.
Okay.
So now you get the idea. Unicode contains letters and digits not only from the Latin character set.
Okay.
See, that is a Latin. Fine, what we write in English, that's Latin. It's a script. Okay. Whereas we also have Gujarati script, we have the Devanagari script, we have all the scripts.
Yes.
Okay, all the scripts of the world, they are included in Unicode. So Unicode is a large character set. Okay, contains lot of characters. Fine, and as far as char type is concerned in Java, char type in Java is concerned. Okay, the char type of Java is 16-bit.
Yes.
So okay, I'll come back here. Okay, so that we can write it here. Yeah. So what is char in Java? 16-bit means what's the range? Zero to okay 2 to the power of 16 minus 1. Okay, when 16-bit basically. Okay, the char in Java is not the entire Unicode characters. It cannot represent all the Unicode characters. Okay, right. Unicode characters. Okay, I can so. Zero to okay, which basically I'll tell you what it is. It is 17 multiplied by 65536 okay minus 1 okay fine. I think if you can use hexadecimal, it may be better option.
Yes.
Okay, fine. So here if I say it's from 0 to FFFF, right?
Okay.
In hex. Okay, I can put 0x here, right? Same way here it is from 0 to 0x 10FFF 10FFF. That's a range. Okay, so Unicode characters are in this range.
Okay.
0 to 114 yeah, basically this value is nothing but 17 times the value of the range here. It is 16-bit values, right? 65536 means the 16-bit values. Okay, that into 17. This is what is available for Unicode. Okay, and I'll show you something here. Okay, so that you can understand the Unicode part. Okay, so Unicode is in the range. How it is 17? It is from 0, 0, okay, up to okay. This is where I have kept initial 2 bits, 2 hex digits as 0, 0. Okay, then it will be 0, 1, right? 0, 1. Okay, so like this, when you go ahead, okay, and you will come to 0, 9 and then 0A. Okay. If you fine, go ahead and you go up to FF 0 F F F F F minus up to not minus 0 F and F F F F. Sorry, this is 0. This would be 0. Okay, and 1 0 is the next thing. So we actually say there are 17 planes. Each one is one plane of the Unicode. Okay, this plane here is known as the basic multilingual plane. Most of the characters are lying here. Okay, other part is not full. Fine. You actually have various versions of the Unicode character set. Fine. I think latest version is 15 or 16, somewhere around that. And 15 was already released. Okay. Fine. So this point onwards, everything here is known as a supplementary character. Okay. Yeah. So BMP, that this one is BMP. Okay. So BMP contains most of the characters. What may be more important or more useful to us here, okay, would be to know that yes, as far as the Indian scripts are concerned, okay, so Indian scripts are in the range from 0900. Okay, I'm just showing the 4 digits, 4 hex digits. This is in hex. I'm writing hex now. 097F. So 128 characters. This is for Devanagari 0980 to 09FF. So 128, block of 120. These are blocks basically. This is for okay, 0A00 to 0A7F. That's for Gurmukhi. And then we have 0A80 to 0A FF. This is for Gujarati. Okay, and then we have the other Indian languages here. Okay, and Kannada and Tamil, all of those, Telugu, Tamil, everything. Okay, Malayalam. And so there are many such things. Okay, and similarly, you have more Indian scripts. There are other scripts because most of those Indian scripts have derived from a script. Original script was Brahmi. So Brahmi is also a script available. There are also a script called Kaithi. So you will find these are also there, but they are in the supplementary characters, not in the BMP part. Okay. These you can see they are in the BMP part, right? Within FFFF, but these go beyond that. Okay. And so you will need, it's not that we don't need anything outside of the BMP. Okay, these are also going to be useful. They are categorized as the supplementary characters. Okay. So, okay. One reason of why I have kept them in this order and shown you like this 17 planes. Okay, you can see there are 17 planes, each of 65536, right? Okay. And okay, the reason why I have kept this is then what is Java char type? Okay, what is Java char? The char of Java? Okay, what is char in Java? Okay. Right? It's just a UTF-16 code unit. Okay. Supplementary characters, if you need a supplementary character, right? So this can cover the BMP. Okay. But if you need supplementary character, I have used the word UTF-16. What is UTF-16? It is name of an encoding, which is used for encoding Unicode characters. So Unicode character range is much higher. It is going up to 10FFFF. Okay, fine. This characters from 0 to 10FFFF can be encoded using UTF-16 encoding. Okay, how that UTF-16 encoding actually is done? Okay, fine. So let's look at that. Okay, now within this range of if we understand Unicode characters, the full range given is 0 to 10FFFF. Okay, out of this range, there is a reserved area. There is a small reserved area, D800 up to DFFF. Okay, this is a reserved area. We call it reserved for. So there are no valid characters assigned here. Okay, this is reserved for surrogate pair. Oh, I am talking about a surrogate pair. So when it is a surrogate pair is made up of two 16-bit values. Okay, where we have D800 to DBFF is for high surrogate. And the other region DC00 to DFFF, this is the low surrogate. Okay, and it's put into two parts, high surrogate and low surrogate. Okay, fine. So a supplementary character, fine. Yeah. Okay, any supplementary character okay, two units, two code units. Okay, what is that two code units? One will be, one is first unit. Okay, or rather I should put it like this. It is nothing but high surrogate. Find a value from the high surrogate followed by a low surrogate. And so it's from this range and then followed by this. How it is actually arrived at, that we can understand now. Okay, let's now try to understand how the high surrogate and low surrogate are derived. Okay, so if we have some value x, okay, what is the x having the range 0 to 10FFFF. This is the range for Unicode. Okay, fine. In that case, what will be done if x happens to be, okay, encoding, okay, if x happens to be between 0 to FFFF, okay, we get 1 unit. We only need 1 unit, okay, which is the 16-bit value as it is. Okay, so when we are saying unit, UTF-16, okay, UTF-16, 1 unit is 16-bit. Okay. That 16 represents the size of the coding unit. So my encoding unit is 16-bit. So it fine. So we don't have to do anything if it is in the range from 0 to FFFF. But if it happens to be in the range, okay, if X happens to be from 1, 0, 0, 0, 0, okay, or rather, I'll put that additional 0 here. I'm using hexadecimal currently, up to 10 FF. Okay, we need 2 units. And how it is done, let's see. So what will be done, the steps for deriving the 2 units will be like this. Okay, so first step will be to fine. So X is the value, right? So from X, okay, X, okay, subtract so what will happen? You get a value Y. Okay, let's say that is Y. So when you do this, what happens exactly? What is the range? In the range, what's the range? You have actually, there were 17 planes. One plane is shifted up. It's just pushing one, right? The topmost plane is gone. Everything is pushed up. Okay, so it becomes a 20-bit value. Right? It becomes, so your new range will be from 0 to F. Okay, which is a 20-bit value. Okay, now what is to be done? We need to encode these 20 bits. So the encoding is done in this manner. So now I'll be using binary. Okay, fine. We have 20 bits to be encoded. Okay, and these will get encoded like this. The first of the 2 units, the first unit will be derived by using 110110 as the first 6 bits, and then pick up the high bits. Okay, first, so your bits, you have bits from a most significant bit will be bit position 19 up to bit position 0 totally, okay, which had to be encoded. So from this we'll say bit position 19 to 10. Okay, these are the 10 bits. Okay, so they will follow here. Okay, and these are the, this is my first unit, and second unit will be 110111 followed by, what are the A's? Okay, so this is A's. Okay, okay, the bits from 9 to 0, and they are the B's. So that's how you get it. Now you can know this range again. Want to understand the range, how those ranges are derived? Okay, what is this? I'll put them into 4, 4. Anyway, it doesn't make a difference here afterwards, right? This is F, so we can know. So what's the range for this? This is value, this is fixed, this is going to be D, this is D, hex D, 1101 is D. 10, if it is the lowest value, it will be 8. Okay, we are looking at all zeros, right? And then 0, 0, D800, right? Up to, what's the highest value then? We'll have, A's are all ones then, right? So D, what's the next thing? 1011. That would be 1010 is A, this is B, and this is F. That's a high surrogate. D800 to DBFF, high surrogate. Same way, what's a low surrogate? This and this, yeah. This will be D. What is 11 and 11 and 00 would be C. Okay, and that's going to be 0 and 0. Here it's going to be same way D, and all ones now, right? Everything is 1. So D, F, F. Okay. So this is how the UTF encoding, UTF-16 encoding happens. So in Java, the char is a single unit of UTF-16 encoding. Okay. If it is in the BMP, 1 unit is sufficient. If it is supplementary character, it requires 2 char values. Single char cannot represent supplementary character. Okay. So we have in the Java library, we have methods where it will, so you will have method. Okay, now what is a string? If you look at a string is made up of fine, it's, we call it as a sequence of characters. It's a sequence of characters. So what is character? UTF-16 encoding. So inside a string, right, for inside a string, I can have a character which is a high surrogate followed by character which is a low surrogate. Fine. So you will need 2 chars for a supplementary character. Right. So inside a string, yes, you may have a high surrogate followed by a low surrogate. So 2 char values. Okay, that would mean 1 Unicode code point. We call them as code points, the values in the range from 0 to, okay. Unicode has code points. Okay. And the range is 0 to 10. So that is a code point value. So you will have methods, many methods which are designed to take int value as a parameter instead of a char, so that you can give any Unicode code point value. So in library you will find methods where you will have code points working for you. Okay, so type would be int and not char. Okay, because the range for char is limited. It cannot handle all Unicode characters. And so library will have methods in those, on those lines. And so another important point about the Unicode, and this is related to the Java file itself. Okay, so now let me show you something. We can go back to hello.java and I'll modify the, update the hello.java in a particular way, and let's see this. Actually, your first class, the class which you defined here, instead of writing hello world, you could have written it as Namaste Dunya. Okay, fine. That could be another exercise. But anyway, so now here, you know, what do you think if I write like this? If I make a change, will it compile? It will not give me an error. It will compile. What is 0063? It is the code point value in hex. This is in hex, 63 hex. Okay, it is the code point value for the character C. Fine. Okay, fine, clear. Okay, now I can show you a simple code. So this will compile. I just made the change here. Okay, fine. And another change, for example, here, I don't want to use this A, which is in Latin, I want to use the letter Gujarati letter A. Okay, \u 0A85. That is for the Gujarati letter A.
Okay.
0A85. Okay, so this is the Gujarati letter A, and this should not compile. This should compile.
Okay.
Oh, yeah, you can use Gujarati letter A. Of course, if you are somewhere else, if you are using, you'll have to replace that. So anywhere in the file, anywhere in a Java file, instead of a particular character, you can use the code point value in hexadecimal by using a Unicode escape. \u is the Unicode escape. \u followed by 4 hexadecimal digits. Fine. So these 4 hexadecimal digits, you understand, is your UTF-16 encoded value. So if you are only restricting yourself to not using the supplementary characters, it's fine. Just one Unicode escape will represent one character. So though I have written this is 1, 2, 3, 4, 5, 6. 6 characters are used. This is in ASCII. This is from the ASCII. This is not outside ASCII. Okay, but with the help of this, you are able to write any Unicode character. This is one single character for the compiler. When you give a Java file to the compiler, the first step it does is checks for the Unicode escape, replace them. Replace them. That's what it is doing. Okay, replace them with the actual Unicode character. The Java compiler is compiling a Unicode character based file. First convert into Unicode, and then I'll identify the new lines. Then I'll identify all those 5 types of tokens. I have already identified and kept aside all the comments. Okay, compiler has done that, right? And then it is looking into the first is Unicode escape, then the comments and white spaces identify the tokens. Okay, fine. So on my keyboard, I might not be able to manage the Gujarati letter A, but this is how I am able to mention the Gujarati letter A by Unicode. Okay, fine. I can show this on Linux. Okay, I'll just connect to my Linux machine, and we should be able to see it. Okay, and okay, okay. Another thing which I wanted to show was a tool called JShell, where you can actually, from Java 9 onwards, we have something called JShell.
Yes, sir.
Java shell.
Okay.
JShell. Okay. Interactive way of, fine, you can interactively just type some command,
Okay.
any of the Java statements.
Okay.
Okay.
Yes, sir.
JShell. So this will work. And you should have installed any version of Java 9 and onwards, JShell would work. Okay, fine. So for example, because this is Linux, I will be able to, we have got the fonts to show you. Okay, so I can use, for example, system.out.println and in double quotes \u, okay, 0A85. Okay, fine.
Yes.
Okay, fine. 08 E6. That's a digit 0. Okay, and okay, let's try the other thing, which was like A. Okay,
Yes.
rather than that a, char, okay, and we want to use some identifier. So I'll say \u and 0a85 equals okay. So the variable, that's a variable.
Yes.
Okay. Can I have the variable by the name \u 0a e6 is 0?
Yes.
Okay, so that's an error. It's a digit.
Yes. Non-nasty.
Fine. You can't start with a digit.
Okay.
Okay, and you want that rupee symbol, and what is it? 20B9. Oh, U. We forgot the U.
Yes.
Unicode escape. Yeah.
Yes.
The digit 0 is there in between, and yeah. So this is valid.
Pre-order followed.
Yeah. Okay.
Yes.
Fine. So even if I want to start with, I can put a class definition here also. I can say class hello world. Maybe I keep it as an empty class. So yeah, it's able to create a class. And instead of class, I'm using \u 0063. Oh, that's fine. Still, it's created and modified. And there's no error here.
Yes.
Okay. And so any place, first thing which the compiler is doing is replacing the Unicode escape with the actual Unicode character.
Yes.
Then it's beginning the compilation process.
Okay. First we got all the Unicode.
All Unicode escape. So in your Java file, you can use Unicode escape.
Yes.
You can make it unreadable. You may not put a space anywhere. Just say \u 0020.
Yes.
20 is the space.
Yes.
Okay. Fine.
Yes.
Okay. Fine. So we saw a lot thing about the char type now, right?
Yes.
Yeah. Other types is still pending. Okay. This is, I have to exit from there. Okay. And see, JShell, I can show JShell works here, but I won't be able to manage those Unicode characters.
Yes.
Right? For example, if I said system.out.println, and if I'd said \u 0a85, okay, it won't be able to show it to me. Just says question mark.
Yeah.
Okay. And those characters, the font is not available on Windows for the characters.
Yes.
Okay, and especially on the CMD, okay, on the command prompt, there are very limited fonts which work.
Yes.
On Windows. Okay,
That's why you use.
that's why I have to connect to the Linux machine.
Yeah.
Okay,
Yes.
fine. Okay, fine. So any questions?
No.
We have just begun with the data types. So we'll be going through the data types. We'll see all the data types about each of them. Okay, we have to understand the literals for each of those types, how to write literals. There are a few things. Many of the things are similar to C language. Okay, so which is very similar and very trivial. I will leave them, but other things where the things are different. Okay, and some of the things which I understand normally people do not know about it. All those things I'll point out. Okay, and so we'll continue tomorrow. Okay.